Minerals. The minerals of the upper chalk are but few in number, and like the lower chalk, it contains but one metalliferous ore. 1. Crystallized quartz. This is of frequent occurrence in the cavities of siliceous nodules, shells, etc. The form of the crystals is that of a six-sided pyramid, their colors varying from a reddish-brown to a light blue, amber, gray, and white. 2. Chalcedony is often found occupying the hollows of flints and is either mammillated, botryoidal, or stalactical. It sometimes forms the constituent substance of corallines, alcyonites, and other zoophytes, displaying in the most delicate manner the complicated structure of the originals. Its color is of various shades of gray, azure, and pearl white, and in many examples it is beautifully translucent. Specimens are not uncommon, in which the surface of the mammillated chalcedony has received an investment of crystallized quartz. Trioidal varieties are confined to those nodules which retain a part of their original zoophyte. In some instances, the flint passes insensibly into chalcedony. In others, the line of separation is most distinctly marked. But in all, there is sufficient evidence that the chalcedony and quartz were deposited by infiltration and must have passed through the substance of the flint. On this subject, Professor Buckland remarks that, although in the present compact state of the matter of flint, it is not easy, though possible, to force a fluid slowly through its pores, yet it is probable that before its consolidation was complete, it was permeable to a fluid whose particles were finer than its own, and that the particles of chalcedony, whilst yet in a fluid state, being finer than those of common flint, did thus pass through the outer crust to the inner station they now occupy. Where they also allowed a passage through their own interstices to the still purer siliceous matter, which is often crystallized in the form of quartz in the center of the chalcedony, and so entirely surrounded by it that it could have no access to its present place, except through the substance of the chalcedony and the flint enclosing it. 3. Calcareous spar. This mineral is abundant in the fissures and hollows of the chalk, and forms the constituent substance of the shells and echinites. It is of various shades of amber color, brown, and pearl white. The variety into which the shells and echinites are converted is opaque, and has an oblique fracture. The other modifications generally possess some degree of transparency. In some of the larger bivalves of the genus Inoceramos, the structure is fibrous. The crystals of carbonate of lime are of various forms. The most usual are the rhomboidal, columnar, and acicular. The first occupies abundantly in cavities in the chalk, immediately beneath the turf on Plumpton Plain, and it is worthy of notice that the hollows it occupies have manifestly been formed subsequently to the consolidation of the chalk. In western Sussex, branched cavities in the chalk, apparently occasioned by the decay of Ramos zoophytes, are encrusted by this variety of calcareous spar. Of the columnar crystals, some fine specimens were brought to view by the tremendous fall of the cliffs near Beachy Head that happened a few years since. These occurred in large masses of a yellowish color, and the crystals, when detached, were semi-transparent. Plumpton Plain, Alfriston Chalk Pit, and some other localities have produced similar examples. Obtuse rhomboidal crystals of great beauty have been found in a chalk pit near Alfriston. Their color is of a delicate pearl white, and in their general appearance they resemble the double refracting spar of Iceland, except in their inferior degree of transparency. The cavities of echinites are sometimes lined with rhomboidal crystals of carbonate of lime, disposed in lines parallel with the sections formed by the area of the shell, and the inner surfaces of the terebraculae are frequently 4. Sulfurate of iron or iron pyrites in subglobular and irregular masses is very common in the upper chalk. The external surface of the specimens is invested by crystals of a pyramidal, octahedral, or cubo-octahedral form, and their interior exhibits a radiated structure, possessing a brilliant metallic luster. When broken and exposed to the action of air and moisture, they undergo decomposition with great rapidity, and even in cabinets frequently form an efflorescent sulfate of iron and crumble into dust. This mineral occasionally encloses flints, shells, echinites, etc., and frequently fills up the cavities of the latter. A specimen in my possession exhibits on the upper side a sharp cast of the interior of an echinospatagus, and its base is covered with an elegant group of quadrangular pyramids, evidently the terminations of octahedrons, with their inferior angles concealed. The lower beds of the Flinty chalk in South Street contain detached crystals of sulphuret of iron, remarkable for their neatness and elegant figure. They are usually regular octahedrons, having their planes studded with small quadrangular pyramids, but some examples occur in which the solid angles are replaced by quadrangular planes, forming a crystal with 14 sides. A specimen of the former variety is represented. Tablet 16, Figure 10. A specimen of the former variety is represented. Tablet 16, Figure 10. Organic remains of the upper and lower chalk. The remains of the chalk are very numerous, but notwithstanding the important additions which modern discoveries have made, the fossil productions of this important deposit are still but imperfectly known. The fossils of the French chalk have been described by M. Cuvier and Brongniart, and those of the English by Mr. Parkinson, W. Phillips, and others. The contents of the Sussex beds will be found to differ in many respects from those previously noticed, while many species of fossils described by the authors above mentioned are unknown in this district. In their mode of preservation, however, a perfect correspondence exists in the productions of different localities. They are, for the most part, remarkably entire. The delicate coverings of the crustacea, the spines of the shells, etc., remaining unbroken. In short, their appearance, as Mr. Parkinson justly remarks, warrants the conclusion that they have been enveloped and surrounded by the chalk while living in their native beds, and that this deposition was effected at the bottom of a tranquil sea. In every instance the shells, echinites, madreporites, and encrinites are converted into calcareous spar, their cavities being filled with chalk, flint, or sulphuret of iron. The remains of the softer zoophytes occur in the form of chalky casts, tinged with a yellowish or reddish oxide of iron. This appearance, which facilitates the separation of the fossils from the chalk, results from the decomposition of pyrites. The vertebrae and bones are soft and friable, but the teeth and palates are finely preserved and have the natural polish of the enamel, heightened by an impregnation with iron. The scales and fins of fishes and the coverings of the crustacea are changed into a brown substance, which is exceedingly brittle and fades upon exposure to the air. Wood. This occurs in the same state as that of the chalk marl, but is in larger masses, and the ligneous structure more distinctly exhibited. It varies from a reddish-brown to a deep chocolate color, and the more compact specimens possess the appearance and texture of charcoal. In some instances, the knots or rudiments of branches are perceptible. In others, perforations caused by the depredations of the teredo, and in one example, the tubular part of the shell still remains. Wood is sometimes found in the center of flints. Localities. 2. Leaves. Tablet 9, figures 1, 2, 12. Impressions of a linear lanceolate form, somewhat resembling in texture and color the wood above described, are occasionally found in the upper chalk, near Lewis. These closely resemble the leafy culms or stems of plants, and are undoubtedly the remains of unknown vegetables. In some instances, they are attached to portions of wood. The imperfect state in which these remains occur renders it impossible to determine the nature of the original. From their being associated with the supposed Julie of the larch, it has been conjectured that they are the leaves of a species of larix or pinus, of which the bodies alluded to are the fruit. But as the nature of the latter is very uncertain, the coincidence may be merely accidental. It must, however, be acknowledged that these remains and impressions Tablet 9, Figure 2, represents the usual appearance of the specimens. Tablet 9, Figure 12, is in all probability a flattened culm or stem, with the linear leaves surrounding it. Tablet 9, Figure 1. This appears to be the remains of a winged seed or capsule. The black stain near it is produced by carbonized wood. Localities: chalk pits near Lewis and Brighton. Unknown fossil bodies resembling the supposed Julie of the larch. Tablet 9, figures 3, 6, 9, 10. These are of two kinds. The first differs but little from the bodies already described as occurring in the chalk marl at Hamsey. See description of the chalk marl fossils. The other variety is more elongated, its surface nearly smooth, and it is solid throughout. The constituent substance of these fossils is precisely of the same nature as the vertebrae and other bones of cartilaginous fishes that occur in the chalk. This resemblance is so striking that it is with considerable hesitation I have noticed them in this place, being fully of opinion that they may hereafter prove to be parts of fishes. Hated variety. Which are new. Tablet 9, Figure 3, represents a large example of the smooth kind, from the upper chalk near Lewis. A more perfect specimen lately discovered very much resembles in form the roe of a fish. Tablet 9, Figure 6. This specimen is of a very singular character, and is the only known instance in which the supposed Julie have been discovered in connection with other remains. The substance represented at the base of the drawing possesses the character of bone, but is too much injured to admit of its original nature being ascertained. The mutilated remains of 3 of the supposed Julie are embedded in the chalk near it. Their relation to the substance in question cannot be doubted, but at present the subject is involved in obscurity, and no accurate opinion can be formed of their real nature and origin. Localities: chalk pits near Lewis, Brighton, and Stenning. (4) Fruit of an unknown vegetable? A muciferous fruit has recently been found in the lower chalk, near Lewis. It is of a flattened, oval form, about 2 inches long, and 1.5 inch wide. The surface exhibits a ligneous structure, and the surrounding chalk is tinged with a bituminous stain. In the malm rock of western Sussex, a few specimens of this kind, but of a small size, have been discovered near Bingnor. These fossils closely correspond with Martin's figure of the external covering of Phytolithus nucleus, and which, notwithstanding its diminutive size, that excellent writer was of opinion belonged to a species of Coccus or Areca. Remains of this class of organized beings are very numerous in the chalk. They are referable but to few genera and species. For the most part, they bear scarcely any resemblance to known existing species, and in numberless instances exhibit but slight indications of the form and structure of the original. The stony corals are transmuted into calcareous spar, while the softer spongeous zoophytes are either enveloped in flint or chalcedony, or form chalky ferruginous casts and impressions. 5. Madrepora centralis. Tablet 16, Figures 2, 4. Stirps solitary, cyathiform, turbinated or cylindrical, with numerous perpendicular radiating lamellae, alternately extending to the center, where they unite. Surface longitudinally striated, pedicle slightly expanded. This species belongs to the genus Caryophylla of Lamarck. Its form is exceedingly various, being either turbinate, cyathiform, or cylindrical, etc. The specimens are usually from half an inch to 2 inches in length, and from 0.3 to 0.5 inch in diameter. The external surface is marked with delicate longitudinal elevations, corresponding in number with the lamellae. The latter are perpendicular, alternately reaching to the center of the axis, where they unite at about 0.2 inch below the margin. The intermediate lamellae are distinct and do not extend more than halfway towards the axis. The smaller number of the lamellae and the union of the larger ones separate this species from Madrepora cyathus of Ellis, to which it is nearly allied. The cyathiform variety is represented Tablet 16, Figure 2. The inversely conical or turbinated by Tablet 4, Figure 16 volts. In some specimens of the elongated or cylindrical variety, a mode of growth is observable, which, if not the effect of accident, might constitute a specific or perhaps a generic character. An example of this kind is delineated in Tablet 16, Figure 4. The coral is attached by its pedicle to a fragment of chalk, and is of a regular ciathiform figure, to the extent of about an inch. From the disc of this joint it is produced into an elongated cylindrical body, which is bent nearly at right angles with the base, a peculiarity of shape that must have resulted either from the original conformation of the animal, or from its having been displaced and subsequently extended in a perpendicular direction. The constituent matter of the specimens is crystallized carbonate of lime, which in some examples is translucent and exhibits the lamellated structure of the original, in a very distinct and beautiful manner. Localities: Brighton and Lewis chalk pits. Traporite. Of the compound madreporites, or those which consist of an aggregation of stars, a species has been discovered that differs from any previously noticed by authors, but the specimens in my possession are not sufficiently entire to point out the form of the original. It belongs to those corals which Mr. Parkinson has designated by the term porpital, and occurs in fragments from 1 to 2 inches thick. It is composed of fine perpendicular lamellae, united by very numerous horizontal descipaments. The cells are distinct and obscurely hexagonal, and the partitions simple, as in Madrepora retipora of Ellis, with chalk.